Hello everyone, welcome back. So in previous lecture, I explained about the headstock and the gearing arrangement of the headstock in this chapter metal cutting lathes. Now let us look at back once again and recall about it. Okay, so the topics here are up to this. We are discussing about the principal units of engine lathes. Now there is headstock. Well, okay, we were discussing about the headstock, and there were type 2. There was back geared headstock and all geared headstock. We have seen one video related to back geared headstock, then all geared headstock. Okay, this was about the all geared headstock. The advantages of all geared headstock over cone pulley. This is called as all geared headstock, and this is called as back geared headstock or cone pulley type of headstock. The advantage of this all gear, which were remain to be discussed, that the design permits a totally compact unit with better appearance and large range of spindle speeds. Here, the advantage of all-gear drive was to that the design permits totally compact unit with better appearance and large range of spindle speed. Secondly, the power input and that available at the tool edge are roughly constant at all spindle speed. So here the power input and available at the tool edge are roughly constant at all spindle speed. No belt shifting is necessary. Here in all gear drive यहाँ पे कोई belt shifting की requirement नहीं होगी, ठीक है. All changes in spindle speed being made by simple movement of one or more levers with more quickly and no change of any accident. Here the all the changes in the spindle speed being made by simple movement of one or more levers. Okay, one or more levers are used with more quickly and no changing chances of any accident. Here there are no chances of accident, as well as the no overheaded set shafting is needed as the power is normally taken from an independent motor. So here the no overhead shaft is needed as the power is normally taken from an independent motor. So this was about the all geared and cone pulley type drive. Now let us see it of today's lecture about the thread cutting mechanism. In today's lecture, I will explain about the thread cutting mechanism. So the principle of thread cutting is to produce a helical groove on cylindrical or conical surface by feeding the tool longitudinally when the job is revolving between centers or by a chuck. Here बिटवीन द सेंटर्स, यहाँ पे जो सेंटर है टेल स्टॉक सेंटर और यहाँ पे हेड स्टॉक का सेंटर, उसके बीच में जो जॉब है वो हमारा रिवॉल्व करेगा. और उसका जो थ्रेड कटिंग है वो किस तरीके से होगा. इट इज द हेलिकल ग्रूव कट ऑन सिलिंड्रिकल और कॉनिकल सरफेस फीडिंग द टूल इन लॉन्जिट्यूडनल डायरेक्शन. जो हमारा टूल है उसको हम लॉन्जिट्यूडनल डायरेक्शन में फीड करेंगे. The longitudinal feed should be equal to the pitch of thread to be cut per revolution of the workpiece. जो यहाँ पे longitudinal feed जो होगी वो कितनी होनी चाहिए. It should be equal to the pitch of thread. जितनी हमको pitch चाहिए thread की, कट पर रिवॉल्यूशन हमको कितनी पिच चाहिए तो उतनी फीड होनी चाहिए, ठीक है. तभी हम उस साइज का थ्रेड जो है वो कट कर पाएंगे. Per revolution, the amount of pitch which required for a thread. Now, the lead screw of lathe through which the saddle receives its transversing motion has a definite pitch. और यहाँ पे जो हमारा कैरेज है, ठीक है, वो किस पे माउंट होगा. यहाँ पे जो लीड स्क्रू है उससे वहाँ पे फीड ट्रांसफर होगी टू द सैडल, जो हमारा सैडल है यहाँ पे उसको मोशन ट्रांसफर होगी, पर उसकी भी कोई पर्टिकुलर पिच होगी। जो यहाँ पे जो लीड स्क्रू का जो थ्रेड है उसकी एक पर्टिकुलर पिच होगी। The ratio between longitudinal feed and rotational of the headstock spindle should be found to know the relative speed of rotation of work, and lead screw will result in cutting a screw of desired pitch। यहाँ पे जो लॉन्जिट्यूडनल फीड है और जो वर्कपीस का रोटेशन है, उन दोनों का रेशियो जो है वो हमको फाइंड करना है, ताकि हम रिलेटिव स्पीड फाइंड कर सके of rotation of work, and lead screw will result in कटिंग ऑफ स्क्रू ऑफ डिजायर्ड पिच। यहाँ पे जो कटिंग ऑफ स्क्रू होगा विथ डिजायर्ड पिच वो किस तरीके से होगा? एक तो यहाँ पे लॉन्जिट्यूडनल मूवमेंट होगी यहाँ पे कटिंग टूल की, और यहाँ पे जो वर्कपीस है उसकी रोटेशनल मूवमेंट होगी, रोटेशन ऑफ हेडस्टॉक स्पिंडल एंड लॉन्जिट्यूडनल मूवमेंट ऑफ टूल। जो टूल है वो इस डायरेक्शन में मूव करेगा और वर्कपीस साथ में साथ रोटेट भी करेगा, और इस तरीके से यहाँ पे थ्रेड कट होंगे। नाउ लेट अस सी वन वीडियो रिलेटेड टू दिस, okay, regarding the thread cutting mechanism. The first we insert the shaft, and this is the one simple bore or hole is cutted so that we can easily fix in the tailstock, and here is the simple turning operation. Now it is fixed with the tailstock. Now the finished, first the excess material is removed and good finish is achieved by the simple turning operation. Here you can see a smooth finish workpiece. Now after the turning we are supposed to gauge the threads over it. Okay, so first we have to fix the tool to particular position, and we can cut the threads. Okay, now it shows the how the gearing arrangement and all the lead screw feed, how it can be controlled. Okay, the various values of pitch are provided over here. Then after setting to particular position we will move further. The motion of this over lead screw is fixed. So here the marking is done first before cutting the thread, or we can say the greasing is done so that easily the threads and smooth threads can be cut, and we can see the point of contact as well as the tool comes in contact with it. Okay, yeah, you can see the line. Okay, then the carriage or the cross slide is set to particular angle. Okay, here it is set as the 0 degree because we are going to cut the angle at the 90 degree. Okay, nextly, next thing we have seen this, that this is the perpendicular to it. Now the feed will start. Okay, this will automatically move to the amount of thread we require. Okay, so here you can see how the cutting of the thread smoothly takes place. Okay, then after it is disengaged, then again we can measure the threads with a thread measuring gauge. Okay, with thread measuring gauge we can measure the threads. Sorry. Now next thing, we will run through again the second pass of the thread cutting. Over here we can see a second pass. Same procedure, and you can see the cutting of threads. Again the third pass is taken. Okay, now we can check with the nut and bolt that it is not going. So again the finishing will be required, finishing of the thread will be required because the gap is not as accurate. Okay, So first it is set that the motion is perfect or not. Okay. Then we will go for the cutting of it. Okay. Now you can see the actual cutting taking place, and with the filing the excess chips or rubs can be removed. Okay. The burrs are formed due to the single point cutting. Though, so to get the finish, we use this. Now you can see that it is perfectly cut. Okay. So this is how the thread cutting is done over the lathe machine. Okay. So with this, so this is about the thread cutting mechanism. In next lecture, we will discuss about the leg and other remaining part. So this is it for today's lecture. Thank you very much for listening me carefully. Have a nice day.